EA Prerequisite 3, Fundamental Refrigerant Management is required for all projects since it's a prerequisite. It's important to know terminology for this credit. Refrigerants absorb heat from a reservoir at low temperatures and reject heat at high temperatures. Refrigerant charge is the ratio of refrigerant requirements to cooling capacity provided. And ozone depletion potential and global warming potential are the two factors we're taking in consideration. That's how you really rate which refrigerants are better than others, such as chlorofluorocarbons, known as CFCs, are the worst in ozone potential depletion. And hydrochlorofluorocarbons, HCFCs, are less in ozone depletion potential, but some have amounts of global warming potential. So there's a cost-benefit analysis there. Better are natural alternatives, such as ammonia, which doesn't have any ozone depletion potential or global warming potential. Also could consider desiccant cooling. I've seen this in hotter climates. And carbon dioxide and propane have no ozone depletion potential and low global warming potential. You have to have a very efficient HVAC system in order to use carbon dioxide. A good example in Portland that uses carbon dioxide for refrigerant is the Left Bank building. The intent of this prerequisite is to reduce ozone depletion potential and global warming potential. The requirements are zero use of CFC-based refrigerants in new base building HVAC and refrigerant systems. This is now required of all buildings, but if we're using existing base building HVAC equipment, you need to complete a comprehensive CFC phase-out conversion. You don't see CFCs spec'd in new buildings, but there are many, many older buildings that have CFCs that need to be phased out. So you need to conduct an inventory to identify equipment that uses CFCs, refrigerants, and provides a replacement schedule. This plan should be done prior to project completion, although plans extending beyond the project completion will be considered. Standards, which are important to know for the tests, are the Montreal Protocol on substances that deplete the ozone. So remember Montreal Protocol. The test is multiple choice, so it's important to remember keywords. It has a timetable for the phase out of CFC production, which has already gone into effect. And CFCs and HCFCs will both be phased out by the year 2030, which is important to note. And that CFCs were already banned in the US in 1995. The other standard is the EPA Clean Air Act, which establishes prior to phase out, you need to reduce annual leakage of CFC-based refrigerants to 5% or less. And gives tips on how to do that. In a retrofit, prerequisite applies to any CFC-based refrigerant in existing base building, HVAC and refrigerant, and fire suppression systems. And if connecting to an existing chilled water system with CFCs, there must be a plan to phase them out within 5 years. There is a loophole, which is a small parental lead, but it's not required if a third-party audit shows that the system replacement does not provide a payback within 10 years. You only want to bring this up or consider it if necessary. It should not be used as a way to get out of being responsible, since it's important that we reduce refrigerants that have high ozone depletion potential or global warming potential. Keep in mind, if you are going to actually reference, it needs to be a third party that verifies that it didn't have payback within 10 years. It's not just a claim a building owner can make, which is important. Strategies include certification requirements for technicians, require repair of substantial leaks, safely remove refrigerants from products, select equipment with long service life, and use natural refrigerants. Strategies are very important for this test, and this is a more complicated portion of the test, so it's important to actually go back and study this section. Optimizing energy performance, the most heavily weighted credit in the LEED rating system for new construction and major renovations in version 3. Here's a snapshot chart of how points are achieved for this credit. So it builds on the energy model or prescriptive path to establish your baseline, and these percentages are based against that compared to ASHRAE 90.1. For new buildings, you start earning points at 12% more efficient than that ASHRAE 90.1 baseline. And then for every 2% more efficient, one more point is earned until you get up to 48% more efficient than the baseline. You earn the full 19 points, or there's an exemplary point available if 50% energy reduction over annual costs is achieved. Also check your local and state incentive programs. Many upfront costs for more complex energy efficient systems can be recovered through these incentives and overall operating cost reductions and savings on utility bills. So it's important to do a full life cycle cost assessment. Also note that for existing buildings, it's the same premise, but you start earning points at 8% more efficient than that ASHRAE baseline, up to 46% to get that exemplary performance point. Option 1 is a whole building simulation similar to option 1 for EA prerequisite 2, energy efficiency. This is how you earn the most points. For option 2, you can use a prescriptive compliance path to earn 1 point using the ASHRAE Advanced Energy Design Guide. Similar paths depending on your building type. In option 3, you can earn up to 3 points based on the Advanced Buildings Core Performance Guide. 4 fundamental strategies to consider are reduce demand, optimize building form and orientation to reduce internal loads through shell and lighting improvements, or by shifting load to off-peak periods depending on your utility. These are important to consider in schematic design, and there are many modeling softwares that can help you with that, such as Ecotech, to help you optimize how you can get the most passive potential in terms of daylight harvesting, natural ventilation, which brings us into harvesting free energy, the second fundamental strategy. We are actually starting to maybe passively ventilate your building, harvest daylight or even heating. If you have some sort of concrete flooring on the south side, you can actually collect that sunlight radiated during the nighttime to passively heat your home or building, as one example. You also want to increase efficiency. This can be efficient envelope based on your insulation, type of windows you use in every layer of your building, what type of lighting you use. There are many efficient lighting systems out there. Integrated controls can help with that as well, or daylight sensors so they're not running when not necessary. HVAC systems, having integrated HVAC systems that maybe correlate to a mixed mode, more passive system. And appropriately sizing your HVAC system, and an energy model can help with that. HVAC systems are typically designed to their maximum level due to code, but if you look holistically at your building envelope with your HVAC system and actual usage of the building, you can actually usually downsize those systems. You also want to consider recovering waste energy through exhaust air energy recovering systems, gray water heat recovery systems, or cogeneration. This can be important to consider when you're looking at indoor air quality and increasing your ventilation. You want to make sure to use some sort of heat recovery system for the exhaust air. Here's a snapshot of an energy model that can comply with option 1, whole building simulation. So you want to use a computer simulation model to demonstrate a percentage improvement in the proposed design compared to the baseline building performance rating. All energy costs in and associated with the building need to be included. This also relates to EA prerequisite 2. Similar to that prerequisite, the standard is ASHRAE Standard 90.1 Appendix G, Performance Rating Method. For core and shell projects only, there's tenant implemented efficiency measures that should be included in the leasing agreement. ASHRAE Standard 90.1 Appendix G provides baseline building performance for the annual energy costs for a building design to compare against. You can use process energy default of 25% unless proven otherwise. Note that the appendix is not to be included as part of the minimum requirements to comply with code. It is to quantify performance that substantially exceeds the requirements of standard 90.1. And that's the idea of having these national standards at baseline, and that's why LEED, I think, has taken the lead in green building, because it does refer to universal methods and national standards in order to show how you can quantify performance such as energy. Option 2, more of a prescriptive path. It first identifies the project's climate zone. Use ASHRAE Energy Guide Section 3 to identify recommended roofs, walls, glazing, and other building components. And you want to use the climate zone factor, not energy costs, for calculations in this case. This map shows the various climate zones. For option 2, new construction core and shell, buildings must be under 20,000 square feet and they must be office occupancy. In this case, you use ASHRAE Advanced Energy Design Guide for small office buildings. Here's a case study in San Jose. It was the first commercial office building in the United States designated to meet a net zero energy, net zero carbon emission goal. It's part of the International Living Future Institute's case studies as well. The energy efficiency for the HVAC system and building envelope is estimated to be 40% below 2005 California Title 24 energy requirements. This really takes a whole building design approach. One strategy is radiant heating and cooling for energy efficiency. It's a radiant floor system with cross-link counterflow PEX tubes, typically, using water to convey heating and cooling to the space, which is more efficient than air. And radiant systems can typically use higher water temperatures to provide effective cooling and lower water temperatures to provide effective heating, meaning that the equipment operates at higher efficiency levels. Here's a diagram, cross-section of how that case study operates and how they achieve those energy efficiency goals. See, there are solar skylights, letting in a lot of natural daylight, and adjusted controls managing system to help operate the lighting and HVAC systems at optimum levels. Also, water flows through pipes laid under an open landscape area and passes into the building, where a heat exchanger collects the heat from the water in the winter and uses the cooling effect of the water in the summer. The glass on the exterior is also electrochromatic, helping with daylight controls. So the geothermal heat pump takes advantage of the fact that the temperature below ground remains constant all year round, around 10 degrees Celsius. Option 2, new construction, core and shell, path 2. The buildings must be under 20,000 square feet, must be retail occupancy, and similar to the option before, use the climate zone factor, not energy cost, for calculations. In this case, you're using ASHRAE Advanced Energy Design Guide for small retail buildings. Next slide. Option 2, new construction, core and shell, path 3. Buildings must be under 50,000 square feet, must be warehouse or self-storage occupancy, and project teams must fully comply with all applicable criteria for the climate zone in which the building is located. In this case, as well, you use the climate zone factor, not energy costs, which is what you would use for the energy model, option 1. Similarly, you're using ASHRAE Advanced Energy Design Guide, but this is for small warehouses and self-storage buildings. So it's really based on building type to get more specific about what should be spec'd. Option 2 for schools. Buildings must be under 200,000 square feet and comply with all prescriptive measures identified in the Advanced Energy Design Guide for K-12 school buildings. Project teams must fully comply with all applicable criteria for the climate zone in which the building is located. This is the Advanced Energy Design Guide for K-12 school buildings and also uses climate zone factor, not energy cost, for calculations. You'll see that common theme through option 2. It's important to know these concepts for the test. Option 3, prescriptive compliance path. You can earn up to 3 points. The buildings must be under 100,000 square feet and meet Section 1, the design process strategies, and Section 2, core performance requirements. You can earn 1 point for complying to Section 1 and 2 for office, school, public assembly, and retail. And if you're a healthcare, warehouse, or laboratory building, you cannot comply. Up to 2 additional points are available to projects that implement performance strategies listed in Section 3, Enhanced Performance. So for every 3 strategies implemented, 1 point is available. Project teams must fully comply with Sections 1, Design Process Strategies, and 2, Core Performance Requirements. You can download a copy of the guide and additional info at advancedbuildings.net. Definitely remember the standard for the prescriptive path for this credit is Advanced Buildings Core Performance Guide. Here are the procedures necessary for me in Section 1 of Option 3. Identify design intent, communicate design intent, building configuration, mechanical system design, construction certification, operator training, and performance data review. So it's really encouraging a more integrated design and communication throughout to come up with a comprehensive plan for energy efficiency. Section 2 of the Core Performance Guide is energy code compliance, air barrier performance, indoor air quality, below grade insulation, envelope performance, fenestration lighting controls, lighting power density, mechanical efficiency, dedicated mechanical systems, demand control ventilation, hot water system efficiency, and fundamental economizer performance. So once again, I'm really starting to outline those specific building systems that are going to be more energy efficient. Section 3, for every 3 additional strategies implemented, you can earn an additional point, up to 2 more points. And this is part of the Enhanced Performance Strategies of the Core Performance Guide. This can include daylight controls, plug load appliance efficiencies, heat recovery, variable speed control, demand responsive buildings. This is especially important for peak power production, on-site supply of renewable energy, and so on. So starting to customize more to a building function and energy use and what makes sense. For office type of buildings, plug loads and appliance efficiency can even be more critical. Demand response buildings pertaining even to zones of buildings for things like lecture halls that have on-demand systems based on CO2 readings can help a building be smarter about when it can turn down ventilation rates when those large lecture halls aren't even being occupied. ASHRAE 90.1 G2.4 addresses combined heat and power. Those systems capture the heat that would otherwise be wasted in traditional fossil fuel generation of electrical power. Therefore, they are more efficient and have fewer emissions by reducing peak demand and reducing overall electrical system transmission and distribution losses. So LEED does take this into consideration. There are 4 different cases that are established. You should review this table, but it does not need to be memorized. There are also exemptional modeling requirements, such as natural ventilation. You'll need detailed project description, clear identification of the areas that qualify, documentation of the modeling algorithms, all thermostat, fan, infiltration, and other schedules, verification that the range of unmet load hours. You need to clearly demonstrate that the operational schedule for the natural ventilation system model correlates to anticipated occupant behavior. Other exceptional modeling requirements could be for PV panels, for example. Speaking of PV panels, on-site renewable energy and site recovered energy costs are not included in ASHRAE 90.1 section G2.4, but receive full credit using performance rating method. Examples of on-site renewable energy include photovoltaic or PV panels, wind turbines, and thermal energy. If that thermal energy is actually producing power, not just passive geothermal. Examples of site recovered energy are heat recovered with chiller heat recovery systems or waste heat recovery units on distributed systems. Baseline case is modeled based on the backup energy source for the actual building design or electricity if there's no backup energy. Exceptional calculation method for ASHRAE 90.1 G2.5 helps document measures that cannot be modeled. This could be gray water heat recovery, flat panel LCD computer monitors, improvements to refrigeration equipment efficiency, kitchen exhaust, zone variable air volume occupancy sensor controls, and so on. For the exceptional calculation method, ASHRAE 90.1, you need to document assumptions made for both the baseline and the proposed design, theoretical or empirical information supporting these assumptions, and specific energy cost savings achieved based on the exceptional calculations. This takes some knowledge of the systems you are calculating. EA Credit 2, on-site renewable energy, is the second most heavily weighted credit in the LEED rating system, version 3, for new construction major renovations. The requirements include on-site renewable systems performance as expressed as a percentage of the building's annual energy costs, similar to EA Credit 1. It's based on energy calculated for EA Credit 1 or the Commercial Building Energy Consumption Survey database, since the prescriptive paths do not include energy costs, which this is based on. There are 1 to 7 points available for new construction and schools, and for Cornshell there are 4 points available. It's based on a percentage of renewable energy based on annual consumption costs. There are 1 to 7 points available for this credit for new construction in schools and 4 points for corn shell projects. For 1% renewable energy production for a project, you get 1 point. For 3.3%, you get 2 points. Similar to EA Credit 1, for every 2% more, in this case renewable energy production, you get 1 more point.